Hello, everybody. In this video, we're going to do an algebra review. Okay, and in this algebra review, we're just going to cover a few kind of algebra topics that will be helpful, particularly for the economics courses, right, where some algebra will come up. Okay, so let's dive in. Now, algebra is kind of a set of mathematical tools that we use to solve equations. All right, and when we solve equations, we're typically trying to solve for the value of a variable. And so here I'm just going to kind of introduce some letters here. So let's say X and Y, and I might include A and B from time to time. These are letters, they're placeholders, we might call them variables. Um, they're placeholders for numbers. All right, so we use letters because let's say we don't actually know what the value of X is, for example. Maybe it equals some number, but we don't know what that number is. So we'll solve for it. All right, in this review, what I'm going to do is I'm going to just use these letters as I write out expressions, and I'll show you some of these algebra rules, algebra techniques that we can use for solving equations. Okay, so just to give you kind of a trivial example of what we do with algebra, imagine we had this equation, 2 times x equals 10. Okay, now this is a fairly trivial example. I'm sure when you look at this, you'll know that x equals 5. Um, but what we do with algebra is we will have equations, expressions like this, and we will say that we want to solve for x. That is, we want to figure out what does x equal. We want to isolate x. We want to get x alone and see what it is equal to. All right, that means we want to rearrange the equation in such a way that x is on its own side, and whatever's over here on the other side, that is what x is equal to. And that's typically what we're going to use algebra for. All right, is we're going to use kind of the tools of algebra to help to solve equations for the value of a particular variable. All right. Now, if we were to do that in this case, I'll kind of walk through it and then I'll explain some of the different ideas or principles. So here, what I'll do is I'll divide both sides by 2. That's something we can do. I'll talk more about that later. And then the 2's cancel out, and we'll get x alone. X equals 10 divided by 2. And then we'll simplify that. We know that 10 divided by 2 is equal to 5. So here we go. We have x equals 5, just as we thought. And now we have successfully solved for x. That's what we do with algebra. All right. Now, when we do algebra, we'll use all kinds of tools along the way. And so let's talk about those. All right. Quite a few little things. It might feel a little sporadic, but what I'm going to do is I'm just going to kind of quickly go through different algebra rules. So just kind of bear with me through these. All right. And then in class, you'll have the opportunity to kind of see examples where these get applied or put to use. Okay. So uh, let's just get started. All right, so I'm just gonna lay these out. All right, so here we go. Um, x divided by x equals 1. All right, nothing too surprising there. What I'm saying is that any number or any variable divided by itself equals 1. Or alternatively, if you ever have the number 1, you can just say, oh, well, number 1 is equal to x over x. That's also equal to y over y, equal to a over a. Okay, the number 1 is equal to any value divided by itself. All right, that actually can be a pretty valuable tool, and we'll see that play out as we move forward. All right, I'll maybe the next one I'll do. I'll just point out these again. These are going to seem pretty maybe seem kind of trivial, but bear with me here. Okay, so any variable or any value can always be seen as that value times 1. All right, because 1 times something is equal to that something, right? If 1 times x is equal to x, 1 times y is equal to y, 1 times a is equal to a, and so on. All right. Similarly, if we have the negative of a number, so negative x instead of x, that's equal to x times negative 1. That actually would be quite helpful. Um, The same thing goes for negative x can actually also be equal to x divided by -1. Okay. All right. Um, next, just point out that if you ever have a value and you multiply that value by 0, well, then that equals 0. Any variable times 0 is just equal to 0. Okay, so these are some pretty straightforward things. Let's jump down to fractions. Let's just do a couple of things related to fractions. This will come up. All right, so let's say we have 1 divided by x. All right, we have 1 divided by x, and we're going to multiply 1 divided by x times a. All right, that's the same thing as a divided by x. All right, and you can do this interchangeably. Sometimes it's helpful to kind of break down a fraction into its two parts. All right. Similarly, if you have two fractions, all right, so let's say we have this, let's say we have 1 divided by x um, times 1 divided by y. That's the same thing as 1 divided by xy. All right, so when you multiply fractions, what you do is you just multiply the numerators together and you multiply the denominators together. Let me write this y a little bit better here. Okay. So likewise, if I had 1 times 1 over x divided by, or 1 over x times 1 over x, that would be equal to 1 over x squared. All right, so if you multiply fractions, you multiply the numerators together and the denominators together. At any given time, and maybe I'll explain this one a little bit more, any variable, let's say a, is equal to a divided by 1. All right, so that's actually kind of the extension of what I set up here. So x is the same thing as x divided by 1. Sometimes it's helpful to convert a variable into a fraction. All right, so you can see kind of the extension of that here. All right. Now let's do dividing fractions. So let's say I had 1 divided by x divided by 1 divided by a. So let's do, or we'll use y here. We'll just do kind of a division of fractions. All right, so let's say we have two fractions, one fraction divided by another fraction. What is this equal to? This is a tricky one, but there's actually a nice trick for this. Whenever you take one fraction and divide it by another fraction, what you actually do is you just will take the bottom fraction and flip it upside down and then multiply it together. So this would actually just be equal to y divided by x. So that's a pretty cool trick. All right, so you take the bottom fraction, flip it upside down, and then multiply the two fractions together. So 1 divided by x divided by 1 divided by y would actually just be y divided by x. All right, so this is how to deal with multiplication of fractions and division of fractions. You might also run into the sum of fractions. Let's say I have 1 divided by x plus, let's say, a divided by x. When you add or subtract fractions, the two fractions have to have the same denominator. If they do, then you can combine them. So this could be equal to 1 plus a divided by x. But if they have different denominators, then you can't just add them together. All right, you have to, this does not equal 1 plus y over x plus y, or 1 plus a plus over x plus a. It does not equal that. What you would have to do here is you would have to do some algebra to make the denominators of the two fractions the same. All right, so what we could do to make that happen is we could use the tool that we mentioned a little bit ago. Remember when I said that 1 equals any value divided by itself? Right? So 1 equals x divided by x and 1 equals y divided by y. right? So that's this, we know this is a helpful tool. We also know from what I mentioned earlier that x times 1 is equal to x. What that means is, and I'm gonna add a color here to kind of show you what I'm doing. If what so what we could do here is we could actually multiply both of these values by 1. And say, well, yeah, of course we could do that. That seems trivial. Why would we do that? Well, but 1 equals y divided by y, and 1 equals x divided by x. So if we did that, we would have y divided by yx plus ax divided by yx. And now all of a sudden, we have two fractions that have the same denominator. And so we can add them together. Y plus ax divided by yx. Sorry, my y's aren't very good here. There we go. Okay, so what I did was I used those two tools I mentioned earlier that probably sounded pretty silly or trivial at the time, but I just used them in a pretty powerful way to allow me to combine these two fractions, to add them together. All right, so that is the addition of fractions, and the same would go for subtraction. So all of this would be exactly the same. If this was a minus, this would be a minus all the way through, and there would be the minus. All right, so that's addition and subtraction of fractions. Okay, excellent. Let's keep going. It's gonna be a quick review. All right, so what I want to do next is I want to talk about the some distributive properties. Okay, so imagine that I had this sum, x plus y. And let's imagine I wanted to multiply the sum of x plus y. I wanted to multiply this whole thing times a. All right. I want to take the sum of x plus y. I want to take that first, x plus y, and then multiply it by a. You'll notice here that as I communicate that, I am adding these parentheses. What the parentheses do is they illustrate or they show that the sum of x plus y happens before the multiplication. All right. Good use of parentheses is very important in algebra. It helps to keep your math straight. Okay. All right. So you'll notice the importance of these parentheses. So here what I'm saying is I want to take x plus y and then multiply it by a. All right. So what we have here is we have addition. All right. And then we have multiplication. All right. And so what we're going to see here actually is that multiplication distributes across division. What do I mean? Or I'm sorry, distributes across addition and subtraction. And so what that means is that I can rewrite this as a times x plus a times y. So I can take that multiplication and I can distribute it across the addition. So a times x plus y is equal to a times x plus a times y. This would actually be exactly the same for subtraction, so I'll just make that clear. If we had x minus y instead, that would be equal to a times x minus a times y. All right, this is a very important skill. Sometimes we will have something that looks like the left side of these equations, and we will want to distribute the multiplication and come over here. Alternatively, sometimes we'll have something that looks like this, and we'll want to, quote, pull the a out. All right, so it can go either way. Both can be very helpful sometimes when solving algebra problems. All right, so just want to keep your eyes out for that, this technique. Okay, very good. The next thing I want to look at is exponents. Remember, I'm kind of going very quickly through a lot of things. This would be a little jumpy, but bear with me here. So what I want to do now is I want to look at exponents. All right, so here's a variable x. An exponent is when you have a number that's kind of like superscripted up above the variable, all right? What this means, what this represents, so x squared is equal to x times x. You could have x cubed, that would be x times x times x. You can even have x to the 1/2. That's actually equal to the square root of x. Okay, so these are exponents. In fact, I should just say this number up here is an exponent. All right, I can write exponents also in terms of variables. So I could say x raised to the a power. That would be equivalent to saying I'm going to take x and I'm going to multiply it by itself a number of times. All right, so this is x raised to the eighth power. Okay, we will see exponents all the time in algebra, and we should know some properties about using exponents. All right, so let's take a look at some of these properties. All right, so I talked about how multiplication distributes across addition or subtraction. So let's talk about how exponents distribute. All right, so we could have x times y raised to the eighth power. This is the same as x raised to the a times y raised to the a. So you can see here that exponents distribute across multiplication. All right, but exponents do not distribute across addition. So x plus y raised to the eighth power is not, very important, not equal to, let's see here, is not equal to x to the a plus y to the a. That is not true. Super important. Those are not equal to each other. Okay. So exponents distribute across multiplication. They do not distribute across addition. Same thing actually with division. So you could have x divided by y raised to the eighth power. That is equal to x to the a divided by y to the a. Okay. So exponents distribute across multiplication and across division, but exponents do not distribute across addition, and they do not distribute across subtraction. All right, very important to remember. All right, let's take a look at this. We could have x to the eighth power, and we could raise x to the bth power. All right, we can do that. When you have that, that would be equal to x to the a times b. All right, so we can raise powers to a power, and then when you do that, the powers just multiply. So x to the eighth power raised to the bth power is actually the same as x to the a times b. All right. For exponents also kind of do interesting things when you have fractions. So I could have x to the eighth power divided by x to the bth power. That would be equal to x to a minus b. I could also have x to the eighth power times x to the bth power. That would be equal to x to the a plus b. Maybe I'll put some parentheses around here to make sure it's super clear. That's all in the exponent. All right. Okay, so there we go for exponents. Now what I want to do is I want to go through a couple of kind of examples or some techniques that are important for solving equations. So let's say we have, let's just write an equation here, kind of a simple one. Let's say x plus y equals a plus b. Now, if we wanted to solve this equation, let's say solve for x, and maybe I'll use some different examples here, but overall, we're going to try to solve for x. Whenever we solve an equation, we will want to use some skills. All right, some tools. So one tool is that whenever we have an equation, we can always add the same thing to both sides. I could always add, let's say, for example, d to both sides of an equation. I can always add the same thing to both sides. And likewise, I can always subtract. Whoops. I could always subtract d. I could subtract the same thing from both sides. So I can always do that. Whenever you have an equation, you can always add something to both sides or subtract something from both sides. It's always fair game. Okay? And likewise, you can always multiply both sides by something, by the same thing, right? So you can always multiply by some value. You can always divide by some value on both sides. So you can also divide both sides by the same thing. Okay, so whenever you have an equation, you can always do the same thing to both sides of that equation. All right, so in this case, it's going to go back to the original here. We have x plus y equals a plus b. If we wanted to solve for x, if we wanted to get x on its own side alone, then what we could do is I didn't give myself enough space here. Let me give myself some more space. What we could do is we could subtract y from both sides of the equation. If we did that, we would see, well, y minus y is 0. So that would get x alone on this side, right? Equals a plus b minus y. There we go. We have now solved for x by subtracting the same thing from both sides. All right, we could do another example. Let's say we hit x. So let's say a times x equals y divided by b. And again, we want to solve for x. So if we wanted to solve for x, what we could do here, let's divide both sides by a. All right, now we know that a divided by a, remember, a divided by a is equal to 1. That means on the left side, we have 1 times x. All right, and we know that 1 times x is just equal to x. So now we've isolated x on the left side. Okay, so now we just need to figure out what this means in order to solve it. So what we've done is we've taken y divided by b and divided that whole thing by a. All right, now how do we deal with this one? This is tricky. Well, what I always like to do is kind of use that technique I showed you earlier. Treat this as two fractions, one fraction on top of the other, y divided by b, all of which is divided by a divided by 1. Because remember, a is equal to a divided by 1. Any value is equal to itself divided by 1. All right, now once we have this fraction divided by another fraction, I think we might remember what to do with it. Remember that this is equal to y divided by b times the denominator flipped upside down. All right, and then we know that, I'll write it down here, is equal to y divided by b times a. And there we go. We have x. We've solved for x. Okay, so what I'm doing here is I'm just using all the different little tricks to solve equations, and we'll be getting lots of practice. I'll give you you'll get practice questions to practice these skills. You can come back and watch the video and practice these. All right, but these skills should help you to solve algebra problems. Okay, thank you very much. Hope you have a great day.